your database costs, which at the end of the day is the overwhelming piece of the cost pie, as you pointed out earlier. So I just wanted to go back to that because I thought that was a really great correlation between some of the content we covered earlier and tying that into some of the real feedback we're hearing today from database customers. So I know it's just about time here for us to jump over to the live system. I don't know, you'd like to give the group a little bit of a quick overview of the gear that you're about to run a whole bunch of workload testing on for us. So why don't you give us a quick explanation of what's there and a little bit around how it's not exactly the latest and greatest, which I know is always painful.
That's right. That's right. The cobbler whose children have no shoes, as the old saying goes here. So we have a lab system here. This is comprised of 6 Dell R630 servers. Now, of course, I don't expect you to be familiar with the Dell product line. The R630s are pretty old, actually. These are 2-socket 14-core processors. They are Xeon E5 2680s. So not too shabby, but these are Sandy Bridge processor machines. So this is going back, I think, 6 or 7 years now. Each one has 768 gig of RAM, and we're running Oracle Enterprise Linux 7.2, and we're running Oracle 12c. So you can tell this lab is definitely overdue for a refresh, Anthony. We'll talk about that later, okay? So each one of these 6 machines has 10 1.9 terabyte SSDs. These are standard SATA SSD drives. You know, they're nice drives, but they're not necessarily the fastest and greatest. I think Anthony was earlier mentioning that there's now NVMe options and some much faster options available as well. But these are still not too bad. We use the Flex software to create a single pool out of those 60 drives. Well, that's 10 drives, 6 machines, 60 drives in total. So we created a single pool out of that. And also on our 6 machines, we created a 4-node Oracle RAC database. Now, again, remember Anthony said in the presentation earlier, we would typically not recommend somebody deploy the Oracle RAC database on the same machine as was running the storage server software, right? This is a hyper-converged, and frankly, it's a lab system. It's a non-production system, and we were limited for the hardware that we had. So it works perfectly fine for this, but for production purposes, we would say separate them. On the remaining 2 machines at the bottom there, we also created a couple of single instance databases. And in fact, I did that originally because I wanted to play with filter drivers. I wanted to play with some new Oracle features, as DBAs often do. And I didn't want to have to keep reconfiguring the grid infrastructure in order to play with those new features. So the single instance databases down there on nodes 5 and 6.
And Graham, one thing to confirm, there's no hypervisor anywhere in the mix here. This is OEL.
That's correct.
Natively running with PowerFlex. There's no hypervisor anywhere to be found, right? So this is a true bare metal Oracle Linux deployment.
That's right. Yes, no hypervisor in this example. Obviously, we do support the hypervisor. You can use the Red Hat. You can use VMware if you choose. But in this example, we've gone bare metal, and that's probably what most customers would do with their production workloads. Although, you know, the hypervisor is perfectly fine too. On each one of these 6 machines, there are 4 10 gigabit NICs, and of those 4 NICs on each machine, 2 of them are dedicated to the PowerFlex software, so they're basically coordinating the I/O traffic between the 6 nodes, and the remaining 2 are left open for the application, which of course in our case is the Oracle RAC. The cluster interconnect traffic is going over there, the TNS traffic is going over there. That limit of 4, that's not a hard limit. You can actually put more NICs in there if the PCI bus will support that. You can have up to 8, I believe, and the 2 and 2 also, by the way, is not hard-coded. You can choose any distribution of those NIC ports as makes sense for your application.
And Graham, just to call out currently, right, because like you mentioned, this is pretty old hardware, but our current PowerFlex rack and appliance systems ship standard with 25 gig end-to-end, and we actually also have the option for customers to do 100 gig natively within those systems. So lots and lots of bandwidth capability, but I think what would be pretty impressive, I have a feeling you're going to show us some pretty good performance even on this really old hardware. So with that,
absolutely,
kind of pass it over.
Yep. All right, so I will now start presenting. So there's one last slide here. The Dell Technologies team has a free database assessment process. You know, is your database workload a good fit for Flex? Especially, for example, with Exadata, right? Let's be very fair. They've got some accelerators. Some people use them a lot. Some people don't use them much at all. Is your workload a great fit for Flex? The database assessment can tell you very quickly, and that's a free service that we do for any of our customers.
That's nice. I'll stop sharing.
I will share my remote desktop. There we go. See that came up? Yes, it did. Oh, I think we got a little bit low on the screen. Okay, so I am now going to be in our lab here, and we've got, this is the 6-node lab, and I'm going to just move things along fairly briskly here by kicking off a workload against our 4-node RAC database, using a tool called SLOP. So this is a simple, lightweight Oracle benchmark. It was written by Kevin Clausen, who is a former employee of Dell Technologies and a good friend of mine. So the SLOP tool is essentially an I/O driver for Oracle. So if you think about FIO and how it is an I/O driver for the operating system, SLOP is a very similar idea, but it's driving it through the database stack so that we DBAs can get to see what the database would experience from the I/O, as opposed to just understanding what the operating system is seeing, because sometimes there can be a discrepancy. And one of the things it also does is it creates an AWR snapshot report for us to look at the end of the test, so we can see exactly what the database saw during the execution. So you can see that the workload is starting to ramp up now, and even with our 6 old R630s and our relatively pedestrian flash drives and our limited 10 gig NICs, we're still cracking over 700,000 IOPS on our system here. And if I click on the throughput, you'll see that we've got 5.5 gigabytes per second of net ingest into our SGA from the 4 nodes of our RAC database. Now, you may notice that there's another window down here on the lower right. This is running the DStat tool, and it's running the Linux DStat tool on the first node of the Oracle RAC cluster. And you'll notice that it's recording the CPU utilization here in real time. And you may notice that we are still at about 40% idle on the CPUs. Remember, there's a 2-socket system. There's about 28 cores total on each machine. We're running 746,000 IOPS in our database. We're running a 4-node RAC cluster. We're running the PowerFlex software, and we are still 40% idle on the CPU. So this is a very powerful, very lightweight software that delivers absolutely outstanding performance, even on relatively old hardware. You may also notice next to that is a column that is recording our network interconnects in real time. That's got ingress and egress on the network ports. You may notice that we are running at about 2 gigabytes a second on each node, which is about the saturation point of 2 10 gigabit NICs. And so if we wanted to get more performance, we would be definitely wanting to get Anthony to deliver those 25 gigabit NICs and get a better throughput on our overall system. But still, 745,000 IOPS into our database, that's really not too bad for this gear that, really is relatively old now. So what I'll also do is I'll show you the back end of the system, right? So here are the back end description. Now, this is the older interface. You may notice that the VX Flex branding is in the top right. This lab is overdue for refresh at the moment, but it's still a pretty good test space to see what you can do with this kind of hardware. You'll notice that we've got here in the white on gray is one of our nodes, SDS1. As I scroll down, there is node 2, 3, 4, 5, and 6. And you may also notice that the I/O from our database is being very evenly distributed across all 60 drives and all 6 nodes of our cluster. And this is one of the key powerful features of the system. We absolutely try to avoid any bottleneck anywhere by distributing the workload across all the available resources, such that we can give you the 749,000 IOPS into the database. On the front end, what the Flex calls the front end, and what we DBAs would probably call the ASM disk group, you'll notice that we scroll up here. We'll find the disks doing this. I happen to know for a fact that it is these 4 here. These 4 volumes are the 4 data ASM disks for the disk group for the database that's driving that workload. And you may also notice that, of course, the ASM is distributing the I/O across all 4 of those very evenly. Now, we still recommend that you follow Oracle's best practice around ASM, so 4 disks per disk group. We recommend that you separate out the FRA and also the OCR vote disks. And there is a lot of collateral that we have to help DBAs navigate that process and deploy it in such a way that gives us the best overall performance and manageability. Now, Slob is just finishing up down here and it's generated an AWR report for us, so we can go ahead and take a look at that. And one of the areas I don't know why that did. I must have miskeyed that one. Let's take a look. There we go. Now it's working. So here is our table space I/O. You can see obviously slob data is there at the top. obviously exactly what we would expect from a slob system. Drove all the I/O into slob. 750,000 IOPS that you were seeing there in real time during the test, and the overall average block response time 0.3 milliseconds. So lots of IOPS and pretty spectacular performance off this system. Now, of course, we did the usual vendor thing. We did a little bit of cheating along the way here. So that was a hero test, right? We basically showed you a 100% retest. And that's a very common vendor trick, right? Oftentimes when you look at the small print on any of the vendor systems, the performance that they show, there'll be a little disclaimer at the bottom saying, based on a 100% 4K random read workload, which we DBAs, of course, know looks nothing like any Oracle database that you've ever seen in your life. So let's go to the other end of this extreme. I've just set it to a 100% write test. Are we going to kick off that workload again? We'll use the command recall, and you'll get to see basically how the system operates in a very heavy write environment. Now, one of the things to bear in mind, and I'm a DBA, not a storage guy, but there is no conventional memory caching occurring on the Flex system. So there's no cache to run out of, and you will get linear performance scalability as you add nodes to the cluster. We have 6 nodes. You can go up to 1,024, and some of our larger customers have of course, done just that. But without the cache in the way, you get much more predictable performance as write workloads increase in your databases. So slob is just ramping up here. It's going to connect back to the database. It's going to do its test. And while it does that, I'm going to show you something else that I think is kind of interesting here. I will duplicate my session and move it out of the way, so that you can see that screen in the background as that does that. I will log in. In actual fact, you know what? I'm going to log in as the grid user. Now, I've separated out Oracle and grid because that's the way I like to do it. If you prefer to have them in the same user account, that's absolutely fine as well. So what I'm going to do here is I'm just going to run a quick check. I've just asked the system to show me the mapping of all of my ASM disk groups to my ASM disks to the back-end infrastructure volumes coming from the VX Flex. So one of the things that I found in the past as a DBA is I've had a problem with my infrastructure. What may be to me, for example, this ASM disk over here, data 1201, when I call Brian for assistance, he doesn't know what data 1201 necessarily is, right? Because it's an ASM disk. With Flex, because there's no HBA, there's no MPIO, there's none of those usual technologies in the way that obfuscate our view. It's very flat and very transparent, which means that I, as a DBA, can self-manage, but I can also see straight through the stack to see what's going on. So this is telling me that my data disk group data is comprised of 4 disks, data 1, 2, 3, and 4. It tells me exactly the Linux SCSI ID that they are. It tells me the WWN ID of the volume, and it tells me exactly the volume name on the back-end system as well. So if I'm in an environment where I'm not self-managing, I can call Brian up and say exactly what the volume is that I think is having a problem with, and there isn't the usual disconnect between figuring out, one vernacular versus another. Our slob is still running here, so we will just let that continue here for a second. I'll also show you just creating some new disks. Again, a very simple process. You come into the system. I'll go into my pool. I will say add some volumes. I will create them. Let's call them dummy. Let's create multiple volumes. I'll have, let's say them 5. We'll make 5 of those. We'll make them a terabyte each. We'll make them thin. And we will say, go ahead and do that. Okay. So I just created 5 new volumes. If I scroll down, I should be able to find them. Here they are. Now what I'm going to do now is I'm going to map these volumes to my RAC nodes. So there is 1, 2, 3, and 4. So there's 1, 2, 3, 4. Map the volumes, and done. So on my RAC node now, I now have 5 new 1 terabyte volumes presented to the cluster. Now at this point, DBAs might choose to use something like ASM-lib or ASM filter drivers. I personally like to use UDEV rules. I think there's a lot of value to using UDEV. It's a little bit simpler in my opinion, but if you feel differently, that's absolutely fine as well. I will just move that window to the side here for a second. And slob is just finishing up, so we'll go and check to see what it saw here in just a moment. Oh, let me move that to the side. I just have a little cheat sheet here for creating UDEV rules. So what I'll do is I'll come in here and show you that. So I logged into node 1 of my cluster, SU into this. And what I will do is I will create a little cheat sheet here to use my UDEV rules. So it's found my 5 new disks. It's created a rule set for me. What I'll do is I'll just save that off into a rules file. And I will restart the Linux rule dev processor. And now if I look in the dev Oracle ASM, so look dev Oracle ASM for our DBAs, we've got our 5 new disks. Now they're on node 1, so what I'll just do is I'll copy them out to node 2, 3, and 4. And I will restart the rule dev processor on nodes 2, 3, and 4. And now, of course, we can just go ahead and create ourselves a new disk group. Let me type that out again, ASMCA.
So Graham, I feel like what I'm seeing here is like a DBA kind of managing the full infrastructure. So I feel like if there's that push towards saying, hey, I want this full stack approach where I can give my DBAs control and access over the infrastructure like I would do with something like an Exadata. It almost seems like PowerFlex can do that. And this is running the old stuff with the old hardware, the old GUI, all the old stuff. But I feel like it's pretty nice story.
Absolutely, absolutely. In many bad cases, the customer DBAs choose to self-manage, right? They want that ability and that flexibility to do that. And so there's absolutely no reason why they shouldn't. The system is simple enough. You really don't need to have a lot of deep technical knowledge to manage the system on a day-to-day basis. Really, the decision about who controls the infrastructure now becomes one of policy. It's not driven by the necessity to have specialized skill sets, which might be the case with many other solutions.
Great.
So I've just told it to go in here and create a new ASM disk group. I've set it to external redundancy. There's my disks. And if I click on OK, and there we go. We just created a 5 terabyte shared clustered disk system here in just a couple of minutes while I was fielding questions from Anthony at the same time. So really a very, very powerful solution to do that. Now, while ASM just finishes up, we'll just show you this. awr1.txt. And again, we'll go take a look at the tablespace area. Oh, I can't type. There's an E in tablespace. Right, and there you go. So you saw, while I was creating the ASM disk group, the system was pushing about 500,000 IOPS through that 100% write test on the system, and you'll see that we still got a 1.2 millisecond block response time on average during that test. Speaking to the fact that, the caching system, without the caching system, the system is still able to deliver spectacularly great performance to the database. And our new disk group has been created, so there it is. It's dummy. It's shared across our system. And I'm just going to quickly here show you why I like UDEV rules a lot. And I think I just lost my window, so let me just see if I can find it again. No, that's not the one. Doesn't matter. You know what? I'll make a new one. That's fine. Log in as grid. So we DBAs do this all the time, right? We create a database, and then the project manager may see that they expect to need about a terabyte of data, so we create the disks accordingly, and then it turns out that that number was completely unrealistic, and they need 10 times that amount of space. So here's my disk group report. You can see that I've got my dummy table space right there. It's 4.9 terabytes as reported to the ASM disk group. Now, I certainly could add more disks to the disk group, and that would be the typical thing to do, right? On Oracle at that point, ASM would start to do a rebalance followed by a compaction phase and all those extra steps that it does. But what you can also do is you can go into the system and you can just resize them. So if I go in here and say increase size, they were a terabyte. I'll make them 1,500. Now they're 1.5 terabytes each on the disk. Now, of course, if I look at ASM, it still tells me that they're 4.9 terabytes. It doesn't recognize the new space. But what we can now do is alter disk group dummy, resize all. And there we have it, right? In just a few seconds, we've increased the size of the disk group by 50%. We've avoided an ASM rebalance. We've avoided the ASM over time. All right, I'll get out of that. So we were talking about IOPS, right? We showed you, what, 750,000 read IOPS. We showed you 500,000 write IOPS. We showed you how easy it is to manage the system. But one of the things that a lot of other storage solutions do not do is they don't handle throughput very well. IOPS, we always talk about IOPS, right? It's the big thing. But people often overlook throughput, and throughput is very, very important for an Oracle DBA. So let's take a look in our system here. I'm going to switch to a Swing Bench database. And I'm assuming most people are familiar with Swing Bench, written by Dominic Giles from Oracle in the UK. Great solution. Unlike Slob, Swing Bench tries to mimic an entire application stack. That's PL SQL, it's referential integrity, it's all the pieces of an application beyond just the I/O that you would find in a real system. So I'm going to set my SID, Oracle SID, to Swing 12.1. And if I log into my database, I should be able to show you the layout. So I'll make that a little bit bigger because this is a fairly big report. And I'm going to do, let's see, SOE object sizes. So this is the SOE schema within the Swing Bench database. You're probably already familiar with this. We've got the order items table right here. We've got 32 partitions in that, 1.5 billion records total, I think, in this database. Absolutely enormous system, absolutely huge table. And what we're now going to do is tell Oracle to go through and sum up and calculate all the records in the system. And while it does that, I'll go back to the dashboard and show you the throughput numbers. So again, we're at a gig a second, and we're going to carry on going up from there. Even with our older NICs, even with our older hardware, we're able to go more than 7 gigabytes per second net ingest into the SGA. So if you've got heavy analytics workloads, you can put those on Flex, and they're going to perform extremely well.
And Graham, just to call out that screenshot I showed a little bit earlier of that customer with new hardware, new system, a half of a floor tile, they're actually doing north of 50 gigabytes per second with their large block workloads. So
I am so jealous.
Some new lab hardware. I think you've earned it. But on that note, Graham, 5-minute warning, just out of respect to our audience.
5-minute warning. You got it.
Yep.
You got it. All right. So tell you what, let's do a couple of more things here. Swing Bench, we're going to kick off Swing Bench right here. We've got a 12C. This is actually running on one of our single node instances. I have to kick off that workload right there. I'll show you where it's coming from on the front end. Let's go to the volumes down here. We got the Swing data sitting, I think it's right there. Let's just go into Swing Bench to make sure that it's actually behaving. Yep, it's coming up. Okay, that's good. All right, now we see the workload hitting the system. Right, so this is 4.8 terabyte database. It's sitting on one of our nodes. It's running that Swing Bench workload right now. I can show you the front end, right? It's running 22,000 IOPS, it looks like. So, you know, a fairly brisk workload. So what you can also do with the system, we mentioned this earlier on, you can make snapshot copies. And I'm using a little Perl script here to make that a little bit simpler for me. Now, the system does have a full REST API, so if you use Ansible, if you use any of those automation tools, you can integrate it using those REST APIs. I like to do things in Perl, but if, you know, you can basically use whatever approach you like. What I'm going to do is I'm going to run the system here to basically, now watch this, right? Watch the Swing Bench runs. It just made a snapshot copy there. It took about, what, 3 or 4 seconds to actually do that while we're hitting the system with 26,000 IOPS running through. And this script that you're seeing running right now will mount that copy. It will rename that copy. It will roll it forward and bring it up to a fully read-writable state. So that copy is just as usable as the production copy that we copied from. And this is a very powerful feature. Imagine if you're in the middle of a production outage. Imagine if you call Oracle for support and they want you to try a patch and you're not sure if it's going to make things better or worse. Imagine if you can instantaneously copy the database, mount it somewhere else, try out that idea, and satisfy yourself both on functionality and timing before you actually go and do it on the production copy and potentially make a bad problem even worse. What's more, we didn't use any space. That's a 4.8 terabyte database, and we've used practically no space to make a copy. You can make 128 copies of every ASN disk in your database. So potentially 128 copies of every database. And since it doesn't require any space to do it, and any time to do it, that becomes a very, very powerful feature for DBAs to be able to use. This system is wrapping up now. It's doing a media recovery on the copy that it's made. The primary copy is continuing to run, and we will let that finish up. So that takes about 2 minutes. 2 minutes total process if you actually want to bring it up to a fully rewritable state.
And Graham, if we were going to do that, what I'll just say, like the typical way a DBA would do it, using some other type of system, like, what are we looking at timeline-wise?
So to do it with an RMAN database, to copy a 5 terabyte database, it's probably looking at a couple of hours to do that. Plus, you would also need to have the space to actually land that copy on. So it can become a very time-consuming and cumbersome process. Now, to be fair, some customers have invested in technologies like Delphix or Activio to do these functions for them, and those are fabulous solutions, but they too also need more storage, and they are not inexpensive. So, Anthony, as I understand it, this functionality comes at no extra cost with the Flex infrastructure. All right, so that copy is now finished, and that's where we see that it's 1346 that the process finished. It started at 1344, so there you go. 2 minutes to completely clone a 4.8 terabyte database while it's running a heavy load, taking up practically no space whatsoever. And what I will just do you want me to do the last piece of the demo now? You know what, I'll get rid of that. I'll get rid of that copy since we're running out of time. What I'll do instead is I will bring up Swingbench against the RAC database. Let's see, we have a RAC 12, there it is. Kick off that workload, let that get ramped up. There it goes. So we should start to see some load hitting the system here in just a second. Oh, you know what I should do? I should probably get this other one to shut down. Let's get that one to go away. That'll be better. Okay, that's good. So what I'm doing is I'm bringing up Swingbench now on the RAC database, the same one that you saw me run that throughput test on just a few seconds ago. And you can see that we're running at about 164,000 IOPS through the system right now. And what I'm going to do here is just show you how well Flex handles failures. Now, Anthony was talking about this earlier in the presentation, the resiliency of the system. Now, of course, bear in mind, ordinarily there are ways to tell the system when crazy DBAs are about to log in with the root privileges and do crazy things. But just for the purposes of showing you today, I'm going to log in as root into one of my nodes. It would help, of course, if I got the password. Maybe Brian changed the password to stop me doing this. There we go, I logged in as root. And remember, we are HCI, we are running both databases and storage. I'm gonna go in here and basically blow the system up. Right, so I've killed off one of my 6 nodes. I killed off one of my nodes here. And just in just a second here, you'll notice that it will detect the problem and start the rebuild process. Now watch the IOPS. We were at 600,000. It's dropped down, and it's coming right back. Right there, we're back at 323,000 IOPS already, and it's still climbing, even as the system detects the failure and starts to rebuild around it. Let me show you the Swingbench interface.
Graham, I think one thing to point out, you've actually also lost 1/6 of your storage capability. So like 1/6 of that old hardware. Now you're like, there's only 5 of them left. Still pretty
That's
good.
right. Yeah, and you can see in the Swingbench interface right there, you can see that failure was detected, but look how quickly it came back. Within just a couple of seconds, we are right back to where we started. Our end users probably saw no impact whatsoever from that, maybe a momentary pause in response times, but we're already right back to where we were, and we are rebuilding. And the reason it's doing that is because we told it to, right? We can go into the back-end system, and in the event of a failure, you tell the system what you want it to do. It's a complete inversion of what normally happens with infrastructure. Normally, the vendor tells the customer. In this case, the customer tells the vendor what we want to happen. We told it to favor Oracle. We can go to the other extreme and say, rebuild thyself as fast as you can. And if I now go to the interface, you will notice that the rebuild speed will start to go up, and the application IOP load will start to come down as resources are redirected to that recovery operation. So this is a very, very powerful feature for your Oracle databases. And you can essentially say how many simultaneous drives and node failures you want to be able to sustain and still be able to provide that application throughput. And it's not an on-off switch. It is a balance beam. You can choose where you want to be on that, and you can change your mind anytime that you like. So if you start up at one end and you want to move somewhere else later on, it's not a problem. All right, I think that's basically the end of the argument. Leave Brian some time to show you the new interface, which is much nicer than this old one. Anthony, we're overdue for an upgrade.
Awesome. Yeah, that's for sure. And I think you've earned it, Graham. So I promise we'll get some new equipment coming your way. You hit stop
All
share.
right.
And we'll actually,
Yes, sir.
Respect to the audience's time, we'll do a close here while Brian shows a much prettier interface. Again, for a full deep dive into PowerFlex itself, along with all the new functionality, as well as PowerFlex Manager and all of the automation and lifecycle management it provides, there's a whole other webinar series taking place. If you would like to see it individually, certainly reach out to your Dell Technologies sales or pre-sales team, and I'm sure they'll be happy to facilitate. But brand new GUI, all HTML5 based, full stack lifecycle management of compute, network, storage, hypervisor, OS, and everything in between, all delivers that full stack engineered system. So when you start to think around your databases, how do I deliver a true database platform? How do I consolidate and simplify my infrastructure to deliver a true transformative experience? Think of PowerFlex. Thank you very much for your time. Thank you for your attention. Hopefully this information was helpful. If you'd like to learn more, certainly reach out to your Dell Technologies account team, and I'm sure they'll be happy to share. Thank you, everyone. Stay safe, and hope to see you again soon. Take care.
Yep.
Thanks, everyone.